Good afternoon, teenagers. It's Mr. Williams, and I am going to be going over your homework problems from last night. So we are in the night book. And the problems that I gave you are on page 60, number 42 and 43. Number 42. Ball bearings can be made by letting spherical drops of molten metal fall inside a tall tower called a shot tower and solidify as they fall. That's really cool. If a bearing needs 4 seconds to solidify enough for impact, how high must the tower be? What is the bearing's impact velocity? First step, always draw a picture. So here's my tower, and here's my ball bearing. And I'm dropping it, so its initial velocity is equal to 0 meters per second. Final velocity, just before it hits the ground, I don't know. It is falling downwards, so its acceleration is negative 9.8 meters per second squared. I do not know how long it falls for. And the height it falls through is also unknown. So I got my 5 kinematic variables here. The only thing new that we've not done in the past is this is in the y direction instead of the x. So then my kinematic equations are and delta x or delta y, it doesn't matter. I'm going to leave it as x because that's the way I have it memorized, but it's really y here. What did I need? Part A asks for the height. So if I want the height, I could do, I'm liking this equation right here because if the initial is 0, so that goes away. I know A. Oh, wait a second, I don't know T. So this is out. I can't use this. This doesn't have X in it, so I can't use that. So this is my baby right here. So my equation has to be and V initial is 0, so that goes to 0. I rearrange it, divide both sides by 2a. I'm going to get delta y is equal to Vf squared over 2a. So Vf, oh, I don't know Vf either. I've got a problem. Well, shoot. You know, I can't use any of my equations. I have Vi and A, but I don't know Vf or T or delta y. Oh, I didn't read the question carefully enough. T is 4 seconds. All right. So I was in a hurry and I didn't read the question carefully enough. You might have been in this situation in the past, and now you get to see your teacher be in that situation. The difference between an expert and a novice, one of the differences is that experts are able to catch their mistakes and fix them. So you get to see in real time, this is how a real grown-up person makes a mistake and fixes it. So let's look here. I didn't read the question carefully enough, which is the first thing I told you to do in the problem-solving strategies a couple videos ago. Sorry, but it happens. Now let's see how this changes things. So now I have A and T. Now I'm liking this equation more. We're going to go with this equation. It's still delta y that I don't know, but I'm going to use this equation. Now the initial is 0, so that goes away, but now I know A and T, and I'm looking for this. Okay, so this is good. I don't even have to rearrange, no algebra. 1/2 times negative 9.8 meters per second squared times 4 seconds squared. So 0.5 times negative 9.8 times 16. That's negative 78.4 meters. So the change in my height as the ball bearing drops down, change in height is negative 74 at 78.4. And the question asks me, how high must the tower be? So the tower must be higher than 78.4 meters. So that's my answer for part A. The answer is not negative 78.4. It's not negative because you don't have a negative height. The tower is not underneath the ground. Negative 78.4 means that the ball bearing drops downward 78.4 when it touches the ground. Therefore, the tower must be higher than 78.4. So let's move on to part B. Part B says, what is the bearing's impact velocity? So that's the final velocity. Now I know now I know 4 of my 5 kinematic variables. I'm looking for VF. I don't know X, so I probably don't want this one. Let's do this one because I know all this stuff. AT VF minus VI. So VF is equal to AT plus VI. So that's negative 9.8 meters per second squared times 4 seconds plus the initial velocity is 0. I could have just crossed that out of here. So let's plug that in. Negative 9.8 times 4. That's negative 39.2 meters per second. All right, let's see. Does that make sense? Yes, it does, because the velocity, see, what I'm looking at is the negative on the velocity. Does it make sense that the velocity is negative? Yes, it does, because the ball is going downwards. So since the ball is going downwards, its velocity should be downwards, so it should have a negative velocity. Let's move on, number 43. I think 43 is next. 43 in the notebook. Number 43, here is an interesting challenge you can give a friend. Hold a $1 or larger bill by the upper corner. Have a friend prepare to pinch a lower corner, putting her fingers near but not touching the bill. So the other kid has their fingers right here. Tell her to try to catch the bill when you drop it by simply closing her fingers. This seems like it should be easy, but it's not. After she sees that you have released the bill, it will take her about a quarter of a second to react and close her fingers, which is not fast enough to catch the bill. How much time does it take for the bill to fall beyond her grasp? The length of the bill is 16 centimeters. So I'm going to draw a little picture of the bill. And this height is 16 centimeters, which is 0.16 meters. And it's going to fall past, this is my finger. So it's going to fall past the finger. The initial velocity is equal to 0 meters per second. The acceleration is negative 9.8 meters per second squared. I do not know what the final velocity is. And I do not know, it takes, the time is 0.25 seconds. And my equations are well, I call this delta H. I should have called it delta Y, I guess. It doesn't really matter, height or the Y direction. So the question is, how much time does it take for the bill to fall beyond her grasp? Well, actually, so this is how long it takes the kid to react. And the problem just straight up told you that this is too much time. Like the bill, when it falls between her fingers, it takes her 0.25 seconds to react, but it's already fallen all the way past her fingers by the time she closes them. So how long does it take for the bill to just be like right here where she could just catch it? Well, that's the morning bell. You guys are about to walk in. I need to finish this video up. So let's see how far. Oh, so the time is actually a question mark then. I've got 3 kinematic variables. I'm looking for time. I have y, a, not t, v initial 0. I like this one. I like this. I'm going to use the second one. The reason I like the second one is v initial is 0, so this goes to 0. And I want to solve for time. So, and I have y and I have a. So I'm going to multiply both sides by 2 and divide by a and take the square root of both sides. So 2 delta y over a, take the square root of both sides, is equal to t. That's going to be equal to the square root of 2 times 0.16 meters divided by, wait a second. I see a mistake. Is this going to be positive or negative? It's 16. Well, if it's a change in height and the bill is falling downwards, this should be negative 16. It's going to be negative 16. Shut the door and stay outside. It's going to be negative 16. So then this is negative 9.8 meters per second squared. The reason this is 16 is the bill is falling downwards. So its final position in y is larger than its initial position in y, and its final position minus initial position, so it's going to be a negative number. So t is equal to the square root of 2 times negative 0.16 divided by negative 9.8. And that's how I knew I had screwed up. When I saw I was about to take the square root of a negative number, I knew that I had made a mistake somewhere. So the time is 0.18 seconds. So that's why 0.25 seconds, which is her reaction time, is not enough to catch the bill. All right, I hope that was helpful for you. And I'll see you in just a minute.